All right, so now we are going to find volume using cross sections. So far we have found volume using disk method and the washer method. So now we want to find volume using a known cross section. So what does that mean? What is a cross section? How do we build this solid? All right, and I'm going to show you exactly how to do that. Just a second. So our outcome is that we'll find the volume of a solid formed by an area and a known cross section. All right. So we've got to have a base area and a known cross section. So let me show you what that means. All right, some crazy pictures here. All right, solids with known cross section. Okay, so these are not solids of revolution. So we are not doing any revolving around. So we're not going to have any discs. There's not going to be a washer. All right, we're not going to have any of those anymore. So that means there should be no pi in your answer, because when we were revolving and rotating around an axis, it was making a circle. So that's why in the volume using discs and washers, everything had pi in it. It was always the integral of pi times r squared. All right. Now, this is not going to have pi in it unless your cross section you're doing is a circle or a semicircle. So these are not solids of revolution. Okay, so what this first picture is right here, they started with a triangular region. So you start with a base. Okay, so here's our bottom, the base of this figure. Then what you're doing with the base is you're building a shape on top of it. So then this is building on this one, we're building semicircles on top of it. So you set the diameter here and you build a semicircle. You set the diameter here and you got a semicircle. You set your diameter here, semicircle. So this ends up looking kind of like a carrot or half a carrot. All right, so you've got a base area, and then on top of that base area, you build some shape. All right, you build the same shape. You don't change the shape. So you always use the same shape. So in this one, it's always semicircles. All right, now on this one's turned a little differently, but this is still your, like in geometry when you did pyramids and stuff, but this is a right pyramid or it has a right angle in it. So I might start out with, let's see if let me erase this up here. My area, keep it consistent. My area blue is going to be this triangle again. So I might have this triangle shape again. But I'm going to build squares on this thing now. So this is my base down here. But now I'm going to build squares on it. So I put the side of the square here, and then I put the square, and then here, and I got a square, and then here I have a square. I'm building squares on it. All right, and so you get a pyramid type of shape where the known cross sections are squares, or you could use rectangles if you wanted to. All right, so this is what known cross sections are. You start with a base area and then you build a shape on top of it. All right, now there's two different ways this can happen. All right, your things that you build can either be perpendicular to the x-axis or you can be perpendicular to the y-axis. So you can put your cross sections different ways. So on the pictures I drew here, it depends on where my x and y are. So in this drawing, it has this one labeled x and this one labeled y. So the pieces went in this way. Okay, so that meant they were perpendicular to the y-axis. All right, and if I kept the same orientation, if this is the y-axis, these were perpendicular to the y-axis. All right, but if I labeled it differently, if I called this the x-axis and this the y-axis, then in this case, they were perpendicular to the x-axis. So it just kind of depends on your orientation. Okay, so you can be perpendicular to the x-axis. All right, so in this picture, the x-axis is here, and then this is the y-axis. So this square is perpendicular to the x-axis, and here's the base shape that they did. They did kind of like, it's not really a quarter circle, but it's close. All right, so there's your base area, and then you put on it squares. You build squares that are perpendicular to the x-axis. All right. And so there would be another one back here standing up like this. Okay. Then you could also put them perpendicular, same thing. I could use the same base, the same exact like quarter circle thing. And I could turn the squares, instead of making them perpendicular to the x-axis, we could turn them and make them perpendicular to the y-axis, okay? So now they're perpendicular to the y-axis. So there'd be another one back here standing up real tall like that, all right, inside that shape. So you can have your shapes that you build on top of an area. They could either be perpendicular to the x-axis or they can be perpendicular to the y-axis, okay? When you're perpendicular to the x, you're in x's. If you're perpendicular to the y, you're in y's. Pretty easy, right? Perpendicular to the x-axis, we're going to be in x's. Perpendicular to the y-axis, our equations and our integral and everything is going to be in terms of y, okay? Now, notice it says the volume is the integral of A. The volume is the integral of A. Well, A is the area formula of the cross section. So whatever your cross section is, that's the area formula that you integrate. So in this case, if these are squares, I would be integrating from A to B side squared dx. And I would want to represent, let's see, I'd put the parenthesis in the other place. I'd want to represent the side as functions of x, okay? So it would be whatever the side of your square is, side times side, side squared. All right, so this is actually much easier, I think, than the discs and washers, because all you have to do is integrate the area formula of what they're asking you to build, all right? So on this picture back here, since these were semicircles, I would be integrating 1/2 pi r squared. And I would just have to represent r in terms of, let's see, these were perpendicular to the y-axis, so that would be dy. So I would just have to represent this length here and find the radius, so I'd be doing something divided by 2, and I would have to represent that in terms of y's. So that's all you got to do is integrate the formula of whatever you're building on top of your area. So this was semicircles, which is half a circle, so 1/2 pi r squared. So that's what you do. You integrate whatever area formula you're building, okay? So that leads us to what kind of areas could we build, okay? So what kind of popular cross sections do they want us to know how to do? All right. So the popular ones that they have us do are squares. So squares are side squared. Of course, it's base times height, length times width, but of course, the base and the height and the length and the width are the same, so it's just side squared. All right, rectangles, you can do base times height or length times width. It doesn't matter which way you refer to it, but with rectangles, it's going to be 2 different dimensions. Semicircles, your area formula is going to be 1/2 pi r squared, of course, half a circle for a semicircle. Equilateral triangles are radical 3 side squared over 2. That's just the formula. At least I think it is. Though I think it's over 4. Sides, I think it's radical side squared over 4. Let me double check, make sure I don't lead you astray. I was trying to find one real quick. Yeah, it's radical 3 over 4. Yeah, I was like, I think it's over 4. I don't want to lead you straight. All right, so for equilateral triangles, it's radical 3 side squared over 4. That's the formula for the area of an equilateral triangle. Radical 3 side squared over 4. And then for an isosceles right triangle, well, it depends on the way it's turned, but that's going to be 1/2 base times height. And since it's an isosceles right triangle, it depends on whether your leg is down or whether the hypotenuse is down on the bottom. All right. So if it's got the leg down, then this leg it's just going to be whatever that leg is. Okay, it's going to be 1/2 the leg squared. Okay, because the length of this is your base and your height. So 1/2 leg squared. So that's okay there. If the hypotenuse is down, then it's going to be 1/2 the hypotenuse divided by radical 2 squared to give you the area. Because in an isosceles right triangle, this is n from geometry, n, and n radical 2. So in order to get the length of the sides over here, you have to divide your hypotenuse by radical 2, and that'll give you the length of your side. And then you can do 1/2 length base times height. All right. So it depends on whether your leg is down. If one of the perpendicular legs are down, then your base and your height are the same, and so it's 1/2 the leg squared. If the hypotenuse is down on the base, on the area that you're building, then you have to divide that hypotenuse by radical 2 first, then square that, and then 1/2. Okay, so 1/2, it's just 1/2 base times height, but it's just how you find your length and your width, and they're both the same number. Okay, I know that was totally confusing what I just said, because I know, I totally get it. All right, so these are the easier ones. Okay, these are the easier ones. This is just a standard formula, radical 3 side squared over 4. All right, that's just a standard formula. And then for the other one, it depends on, for these down here, isosceles right triangles, it depends on which side of the triangle is laying down on the area, what you have to do to figure out the area of the triangle, because you're going to use 1/2 base times height, where the base and the height are the same. So if the base and the height being the same, if one of those is on the bottom of the area, then it's 1/2 whatever that length is squared. But if the hypotenuse is the one that's down on the area that you're building, if they turn the hypotenuse down, then you have to take the hypotenuse length, whatever this length is, and divide by square root of 2 first to get the length of your 2 legs, and then it'll be 1/2 leg squared. Okay, and if we have one like that, I don't even know if we got one like that, or if we have one in our examples. If we get to it, we'll make sure that we do that in depth. All right, so those are your popular formulas that you need. So all you do when you do cross sections is you integrate the area formula of what you're building. And I put those in order of popularity. Okay, the order that I just listed those are in order of popularity. They really like squares, rectangles, and semicircles. They love those. Then they are okay with equilateral triangles, and then every now and then you see an isosceles right triangle, but not a whole lot. All right, so those were in order of popularity. So, all right, so now you are ready to look at the example video.